It's time for a weekend project, and it's not this fabulous little LED disco light that has just arrived from China. And it is actually really impressive, but I'm going to cover this in a different video. I'm having to wait for some leads to arrive because I went to my lighting desk and discovered all the leads were missing. That's what happens when you lend stuff out. But here it is initializing, and it's really surprising inside so far. Really very impressive technically. And at the moment it's doing its little test routine, and its LED is pretty darn bright. You know, it projects a decent image across the room, and it has separate colour and gobo wheels. But that's not what this video is about. That is for later. That's just a little teaser of what's coming up. What this video is about, I'll just drop that lead down, is tungsten LED fairlights from Poundland, or wherever else you can get them, with their golden tungsten glow, and how to convert them to LED. And this is, I'm pretty sure I've done this before in a video, but let's do a complete from scratch video. So what we're going to do here is, where's my notepad? We're going to put a very, very simple resistive dropper. We could use a capacitive dropper, but in this instance I'm going to use a resistive one. And we're going to start with a bridge rectifier. I'm just going to draw it crudely here. So that's the AC input and the DC output. And we're going to have a resistor on the live and a resistor on the neutral. Basically speaking, we're using quite a lot of resistors because we should have drawn that a bit bigger, but let's space things out a bit more. I'm using lots of resistors to spread the dissipation because the resistors are basically dropping the difference in voltage at the current of the LEDs, and it means they'll get warm. But they're quarter watt resistors, and I'm going to give you two different values for 240 volt and 120 volt, just so you can, you know, wherever you are in the world, you can just adapt. Now the bridge rectifier is going to be one of these generic round through-hole bridge rectifiers, and I would choose one. This one is rated, this one came from Rapid Electronics in the UK, part number 47-3198, and it's at 1.5 amp 800 volt bridge rectifier. So 800 volt, to be honest, as long as it's rated for your mains voltage, that's fine, although actually it won't really see the full mains voltage unless the LEDs are disconnected. So the bridge rectifier, which you'd have to allow for anyway, so a bridge rectifier, in the case of America, I would say a 200 volt upwards rectifier, and in the case of UK I'd say 400 volts upwards, but to be honest, it's so, you know, there's so little price difference between the high voltage ones that you might as well go for the high voltage. So we're aiming at a string of 20 LEDs. So 20 LEDs at about, say, it's going to be a mixture of red, green, we'll average it out about 2.5 volts each, equals 50 volts, which means that on 240 volts, well actually, you know what, we'll say 230 volts, because that is supposedly the European standard. 200 volts minus the 50 volts equals about 180 volts to drop. With 120 volt minus the 50 volts, it's about 70 volts to drop. And that's being dropped across the resistors. So typically, without going to the maths too heavily, we're going to go for 4 times 15k, 15,000 ohm resistors. And that's going to give approximately 3 milliamps through the LEDs, which doesn't sound a lot, but you know, it's subtle lighting, it's ample, it means the LEDs are being totally driven well below their maximum rating, and it's a nice subtle non-in-your-face effect. For the American market and other countries with 120 volt, it's 4 times 4,700 ohm resistors, 4.7k. And that is going to give roughly about 3.7 milliamp. And the dissipation of the resistors is going to be round about, in the case of the British, we're dropping a higher voltage, it's going to be about 150 milliwatts. So we're using quarter watt resistors which are rated 250 milliwatts. So it's well within the rating, and for the Americans it's going to be less. It's going to be less than 100 milliwatts. It's going to be well below half the rating of the resistors. I should actually have looked out the resistors, but not to worry. Oh, and you know what? Also, previously when I was playing about with these circuits, I added another LED in line up here. And the reason I added it there is just because it means that the little power supply we make can also glow to show it's on for no particular reason at all, other than the fact it's potted in resin and it will glow, which, you know, it's just a nice feature and it's easy to do. So what we're going to do is the bridge rectifier, actually I'll just draw that in 3D. It's going to have the positive connection coming out and the negative connection coming out. And I'm going to add the LED in. It's going to be a straw hat LED, and it's going to just be coming down like that and tacking onto that lead, and then going out to its appropriate resistor. Whereas the other resistors are just going to be coming straight down onto the pins. And likewise, there's going to be the AC pins are just going to be in these positions, and they'll both have resistors, but I won't draw them in just because it makes it easier to see like this. So this is going to be positive connection LED, and this is going to be a negative connection, and it just, you know, you'll see when I actually do it. That's the best thing to do. So let's go and grab the resistors. So I've got 4 15K resistors. One moment please. $15K resistors. The rectifier, and I'll just put this out the way at the moment because the white of the paper tends to swamp the image a little bit. Now, the rectifiers are not just marked on the back as what each pin does, but they also have a longer positive pin. So I'm going to cut all the leads down. To give better access, including the positive one because it is still marked on that side for reference. And I'm going to start by getting my little straw hat LED and bending the positive lead down, cropping it, and then I'll tin its lead and the rectifier's lead. I'll have to I'll start off soldering this by hand, but then I'll have to get the little helping hand thing in just to hold these. So I'm going to tin that lead. I'm going to tin that lead. And to be honest, I can just solder these together, so I'm just going to solder that on like that. This is where it starts getting a wee bit footery. Okay, so that's the little indicator LED that's going to be in the completely resin potted power supply. It's just a nice feature, it's not really needed. The reason I'm using 4 resistors, apart from spreading the dissipation, is it's just easy to solder one onto each lead of the rectifier. It just makes it so easy. And the current path through the bridge rectifier is such that at any time all the resistors are in circuit anyway, so it doesn't really matter. Now this is where I will need to grip this in the little magic helping handy things, whatever they call them. And I'll tin the leads of the rectifier and add the other. I'll also tin the other lead of the LED. Cloud of smoke goes up and obscures the camera. And get the resistors and tin them too. So I'll just crop them down. The reason I've chosen the resistive dropper is just simplicity. It's really absolutely the simplest possible power supply. There's so little to go wrong with it. It's just, and it means the LEDs are being, you know, it limits how bright you can run the LEDs because of the power dissipation of the resistors themselves, since the resistors are sadly dissipating a bit more than the LEDs. But that said, you know, again, it's just subtle Christmas lighting. It's not really, it's not going to, you know, be anything special. It's just going to be a subtle glow. And when you see it, if you make one of these, you'll realise that, you know, it really is surprising how bright everything looks. I think I tinned them already. Yes, I did tin them already. See, I've forgotten that already. So let's add, actually let's add the resistor onto the LED first. I'll crop that lead down. I'll put it on the inside just so it's got a bit more room when I'm actually terminating the wires onto this. Oh, fumbly resistors, they're tiny. I have been doodling an idea out just for a circuit board based on surface mount resistors, so the whole lot is absolutely flat and can then just be like potted effectively with hot melt and heat shrink. Whether this is all electrically compliant, I don't know. Yeah, it's no bad, no worse than what's coming from China, right enough. And I should add there that, you know, China does make a lot of good stuff as well. But it's not half as fun as the crap stuff. So I'm soldering these resistors on. And I see the competition in the previous video for random stuff is going strong. Lots of the fact I woke up to about 500 emails from YouTube indicates, yeah, that's quite a popular competition. The Pink Death is not a sex toy, by the way. I just thought I'd mention that. I mean, it could be a sex toy. That would, you know, that would definitely be something that would happen on this channel. Someone getting a random sex toy as a prize. That would be quite funny. That could happen in the future. Maybe we'll do a special sex toy competition. Because China has no shortage of really bizarre sex toys, and occasionally, when I buy electronic stuff from an eBay seller, for some inexplicable reason they'll say, you might also be interested in this, and then like some sort of purple dildo pops up and it's like, why is a company selling computer modules selling dildos? That's just the nature of China. It's very, very weird. So now here's the lead that's leading to the LEDs from the plug, the typical British square pin plug, and I'm just going to chop that. Where's my snips? There they are. Could chop. That can go anywhere, but it's better to, you know, cut it fairly close to the plug. And I'm just going to strip these just about 1/4 of an inch, 6 millimeters. And likewise, the outgoing wires, which are now going to be the DC wires going out to the LEDs, I'll strip them too. And tin them and solder them on. And this is where it's important to get the wires in the right places. So we've got a positive and a negative wire going out, but at the moment they're the same colour. So I'm going to actually mark the negative wire with a black tie wrap, just as a marker. Because putting the whole thing together and then putting all the LEDs in the correct polarity and then finding it was the wrong polarity and blowing all the LEDs up, that wouldn't be a good result. Okay, you guys would probably find it quite amusing. I'd find it amusing myself. But it's not the ideal result. So we'll tin these wires. And the negative one is going to be the opposite one. Actually, I'll put the positive one first because it's the distinctive one. It's the one with the LED. I'll just clean the excess solder off that. And this is where the wire is suddenly quite heavy and starts pulling all the components out of place. Oh, and because it's got high thermal mass, I have to leave it a bit longer for the solder to harden. I'll cheat, I'll blow in it. And I'll tin these other leads. There we go. And this is the other one going to the LED, so it's going to the negative terminal. I should double check that. I'll do it afterwards, when it's clearly far too late. One of the slight perils of tinning leads in advance, of not actually flowing the solder directly onto them, is that the solder can be a wee bit peaky. It can form little peaks. It's worth making sure you've not got any spikes left over, because we're going to be potting this in a little plastic container, and in this case I'm going to, because I didn't have a little plastic tube that's ideal, I'm going to be using heat shrink repurposed as a little plastic tube, which I'll show you in due course. I'll just twist that wire since it's completely refusing to twist. There we go, that's it twisting there. I made quite a few of these sets of lights because, you know, they're just fun to make and they look fantastic and they draw so little power. They draw typically about half a watt for the whole string, and if you consider the lamps that are already in it are 1 watt, we're talking by the time we've finished with this string, the whole set's going to draw half the power of one of these lamps, which is really impressive. It means you can also just leave it on 24/7 because you don't have to worry about electricity consumption because it's minute. And I've just dropped the solder. 1 moment please. Fresh bit of solder. So this is the last AC input, and this is from the plug. If in doubt, you can always refer back to the image at the beginning of the video. And that's us, that's the power supply. Here it is with the little LED in line, the optional LED in line. It doesn't have to have an LED in line, and I have actually got the polarity right, which is nice. So now let's pot that in, the little cup I've made. So here's the little cup I've made, which is made of heat shrink, and what I've actually done, I heated the end so it shrunk in, and then just grabbed my long nose pliers, and while it was still hot I nipped it, and that tends to make it all stick together, and it just seals the end and stops the resin running out. And to make sure the wires all stay apart, because there's a problem that when you try and push it in, inevitably the wires will all suddenly squish close together, though strangely enough they're not doing it now. But rather than risk that, I came up with a solution of just using this screwdriver, which is a bit footery to get set up, but I'm putting a tie wrap around it. I use this screwdriver because it's got 6 sides and it kind of holds them, but if you get something with 4 sides, that's even better, and it's just to hold these leads apart so that you've got time to get it in, because once the resin's actually in there and it's curing, you can't really do an awful lot. So let's push these leads through a bit. To square the rectifier up. Space them apart, and then we'll get the resin into this, and that will be our power supply complete. So I'm just going to do a wee trial run. That's all staying well apart. Yep, that looks pretty good to me. So let's get the resin into here and make a mess. So here's the Poundland 2-part resin, Poundland set of Fairlights. Screwdriver came with something, I can't remember what that was. That screwdriver came bundled with something. So I'm just going to squirt all the resin out of here in, because I'll probably need most of it. And if I don't, then it's too late. This is going to make a mess as usual. Poundland plant steak as a stirrer. The LEDs I'm going to be using are 10mm diffused LEDs bought from eBay. You can find them, if you do a search on eBay for 10mm diffused LEDs, you'll find random Chinese sellers selling them. And I like the 10mm diffused are quite good because they just produce a nice large blob of light. But you can use 5mm ones as well. And if you have the standard clear 5mm ones, then the other advantage of those ones is that you can then put little shades over the end of them. You can put the little press-on shades. One thing to note though is that you need the ones with the full-length leads. The ones with the wee tiny short leads that often come from China are just not so ideal for this, because they need it for the what we're going to be doing with them, which you shall see in due course. So I'm going to drizzle that resin into there. Maybe hold it at a slight angle so it goes to the bottom. Yeah, he said bottom. And I'm going to put a modest amount of resin in there and try and judge it so that when I plunge the rectifier and the resistors in, it kind of squishes. And it should all squish round it but not pour out the top. Which, you know what, given my clumsiness, it probably will all pour out the top. I'm a terrible judge of things like this. So yeah, that's about halfway up with resin. Yeah, a wee bit more. What's the worst could happen? Yeah, I'm kind of thinking that's probably enough. And now, I'm going to let that all settle down, then I'm going to push this in and we'll see what happens. The resin is squishing around the rectifier, it's going up, the leads are all going in. Yeah, that's good. That's potting all the leads in, so they're all going to be basically secured. Yeah, that's looking pretty good. All the electrical connections are being kept well apart. And now I'm just going to pause the video momentarily until that's all cured, because watching resin dry isn't all that much fun. So I'll be back shortly. Okay, that's the resin cured, so I can now cut this tie wrap and remove the screwdriver that I was using as a spacer. And theoretically, if this is working now, I should be able to plug this into the mains, and the little LED indicator in here should light, but the tungsten lamps will not, because the tungsten lamps are effectively looking like a dead short compared to LEDs. So I'm plugging it in, and the little LED in there is glowing. You'll see a slight shimmer as well because it's not smoothed. That's a good start. Next thing I'm going to do is I'm going to trace I marked the negative with the black tie wrap. I'm going to follow that wire up to the string, and I'm going to put a black dot on the side just to remind me that this is the negative side. So I'm going to put a black mark on that side there because it's important to get the LEDs in the right way around. And then this is what we're going to do. We're going to take out each tungsten lamp in turn, and we're just going to, hopefully, if you've got a set of these, it's not glued in like some of them are, but most of them are just pressed in, and when you pull them, they'll come out like this, they'll just separate. And you end up with a little plastic base that you can put an LED into. And I'll bring the notepad in here because it's a little important detail here. I'll do a little sketch of this lamp holder, which looks like this. Slightly tapered, with a lip at the top. Actually, it's got a little slot in here so it can actually expand round the lamp head just to allow it to fit in and also sort of act as a sort of grip. And then it's got the little support pillars and a space in between them, which is used as electrical separation in the actual light fitting usually, the actual lamp holder. And normally when the lamp's put in, the leads are just folded across the outside and cropped short. What we're going to be doing, we're going to be putting the LED in, and it's going to be quite a big LED, or it could be the small LED, just placed flush against the front. We're going to put the leads in, and we're going to fold them back, like that. And quite an important thing, this little lip here, we want to use the snips upside down and cut into that, like that, to cut the lead by maybe putting the tips of the snips into the little ledge there, and that means the lead will end up just slightly shorter because we don't want the lead anywhere near up the side of the light fitting because it will just make it very hard to put in. So it just needs to be folded round the end of these little spacers. Absolutely do not leave the leads full length because then they'd be sticking out and you could get an electric shock, which isn't desirable. Makes it a very exciting set of fairlights, but not desirable. I've also marked all these LEDs, the negative terminal, the short lead, I've marked them with a black dot, and again you must use the ones with the long leads because the ones that be tiny leads may not actually reach through these. So I'm now going to feed this through. I'm going to fold it round over the end. Take the snips and I'm going to crop it sitting them onto that little ledge so they are just that little bit short. And when I put it in and plug it in, making sure I get the polarity right, that LED should then light. Which it has. Not super bright, but that's deliberate. It's going to be a very subtle set of lights. Then I take the next light out. Keep in mind there are 20 of these, so I'll just start rambling on with random conversation now. So let's use a yellow one for the next one. And I'll just poke these leads through. Fold them over. Now, some of you guys were mentioning when I ran the competition that the ones who had contributed via Patreon were slightly miffed that there was competitions open to everybody. The competitions open to everybody are the prizes are being funded from the eBay, from the YouTube side. So don't worry about that. The bigger prizes will be for the Patreon subscribers. The more interesting prizes will be for Patreon subscribers. Not that I'm discriminating against MD, it's just that's the way it's going to work, just so you know you don't feel cheated in any way. Now, some of you are asking, what was my background in electrical and electronics? Well, the way it works in Scotland, well, the way it used to work, it doesn't work this way anymore. It used to be, keep in mind the polarity here, the negative to the negative side, and as I plug each in, it's going to light. So that's lit up nicely. In the Scotland, when you were young and you start an apprenticeship, the way it worked when I started my apprenticeship around about 1980, I think it was, you had to have started an apprenticeship by the age of 17. If you hadn't, then you just at that time couldn't start an apprenticeship, which it seemed a bit unfair, but it's just the way it worked. I think it was just so, everybody was just the same age group at the same time. But so at the age of 16, I left school. I tried leaving at the age of 15 unsuccessfully because it's not actually kind of allowable. But I made an attempt anyway. I almost ended up going and starting with a company called Hugh Fulton's in Glasgow, electrical engineers. But sadly they found out I was underage, and that kind of scuppered that plan to escape from school. So instead I ended up with a company called Egi Steel & Co. Electrical Engineers when I was 16. And that was the best thing that could have happened. Egi Steel & Co., and that's spelled S-T-I-E-L-L, was a heavy electrical engineering company that specialised in steelworks. So on my first day of the apprenticeship, I was at Glengarnock Steelworks in Scotland in their DC hall. Now, if you've seen the Frankenstein films, you'll have seen the knife switches and all the big ornate dials. That's what their DC hall looked like. It was basically a hall lined with slate panels. And on these panels were the big, huge knife switches with copper and brass blades and the Bakelite handles. And above them were these big dials, these big meters with curved fronts and the really ornate dials. And I didn't realise at the time, but I've just put that in the wrong polarity, but it's a gallium arsenide one, so it should survive. Yes, it has survived. I didn't realise at the time, but there was something in the middle of the room that looked like a big metal turbine blade. I didn't realise at the time, but it was actually a mercury rectifier, about 6 foot tall. It was massive. It was designed to supply DC power to all the electrical equipment in the steelworks, like cranes, all the traction equipment and heavy motion equipment, because all the cranes all operated in about 500 volts DC. So that hall, that DC hall, it wasn't, we weren't in stripping it out or anything like that. We were actually installing it because they'd removed all the equipment from another steelworks. And because the old DC equipment was so much more reliable than the new stuff, they just moved the old DC stuff across. And there was a substation with 11 kV cable coming into it, and the transformer of the halon extinguisher system. I remember that. It's the first time I'd seen a halon extinguisher system. And its output from the transformer was fed straight to that mercury rectifier via protection, obviously. And then its DC then fed the DC hall. And Egi Steel & Co. was all heavy electrical engineering. It was contracting and, construction and in places like Cummins Engine Co. and all the steelworks, Ravenscraig, Clyde Alloy. It was a heavy, really, really heavy electrical apprenticeship, but no harm in that. I quite enjoyed it. In fact, you know, if I could turn back the clock, if I had to do it all again, I would still do it again. It was great. I really loved working in the steelworks. They were really atmospheric. They were pretty much what industry should look like. And we also got danger money because the work was apparently dangerous, and I suppose, you know, people did die in the steelworks. But to me, danger money at the time as an apprentice was just an extra bonus money. I didn't really see it as being dangerous at all. The steelworks were awesome, loved them. When you were walking in amongst all the ingots, if they took ingots out of the furnace to cool down, if you got at the right time that the ingot had cooled down to the point, by ingot I'm talking a huge slab that would go through the rolling mill, if you timed it right when it had cooled down to the point it wasn't glowing red hot, you could just jump up and lie on top of it. And it was incredible, it was so hot. You couldn't just lie in it continually, but it was really nice. We had fairly heavy, thick cotton overalls supplied back then. But yeah, it was nice. Also at places like Craig Nuke Steelworks, Clyde Alloy was the other name, where they did lots of other unusual metals. They poured the metal into sort of conical ingot type moulds, and they were stored in a place that you could, you know, when you walked through it, you could feel the heat, and it was almost like a labyrinth of these pillars of heat, and some were cool and some were hot, and you had to, it was like a maze that you had to work your way through it, feeling as you got closer to some, they got hotter and hotter, and then you had to divert and go in a different direction. It was really weird. And the arc furnaces were incredible. They basically melt or smelt metal by basically lowering electrodes in it like a huge arc welder. And the sound, it's like lightning just ripping, the blasting, buzzing sort of 50 hertz noise from our 50 hertz supply, because these things drew so much power they had their own substations pretty much built onto the building itself with the arc furnace in it. Just absolutely amazing. The noise was just deafening but really incredible. So that's the background. I worked with EGI Steel & Co. for my whole apprenticeship, traditional 4-year apprenticeship, during which time we were trained in maintenance of mercury rectifiers and cold cathode lighting and power distribution. All very interesting. And then I went into EGI Steel's electronic department, where I spent some time before leaving the company and going to various other electrical contracting companies, before ending up with a company called Thomas Johnson Shopfitters, where I worked for, I really enjoyed. We basically went round doing shops. Well, shop fitting, that's not really a surprise, but it would mean working away for about a month at a time, and it was good because when the joiners needed a hand, you helped them, and the painters and so on. It was just a little taste of other trades as well. It was good. And also, because the hours were ridiculous, I didn't realise this at the time because I was young and naive and just did the hours. I didn't realise that I earned enough to actually pay pretty much a third of the cost of my flat in Glasgow, which was great. It meant the mortgage was really low. But, you know, to me it wasn't working long hours. I was quite happy at that time. Because I was still living at home, I was quite happy to be working away, to be honest. I do recommend that if you're young, if you're actually these days it doesn't matter what age you are, get a trade. You know, if you're interested in electrical stuff, become an electrician. If you're interested in mechanical stuff, you know, you can get an apprenticeship as a mechanic. There's just a lot more variety these days. You can start much later, but sadly the apprenticeship system in Britain has just collapsed. They don't really do proper apprenticeships anymore. It's all corporate facility management companies just trying to push people through as fast as possible, so unfortunately tend to throw you in at the deep end, which isn't actually necessarily a good thing. But yeah, it's much better, instead of going to college and learning a trade at college without any real practical experience, it's better to do it for real. And actually, you know, you get paid for learning, which, I mean, what's wrong? You know, that's a great thing. And you come out at the end with real practical experience. It's not like if you go to college and you do a course in, say, electrical installation and you don't have any practical experience, then you're completely unemployable because you've never done the work for real. So the best way is to get an apprenticeship and actually get paid for learning. And I have to say, I would, if I started again, I would just go back and do the same thing again. If I could relive my life, because it just was great. The steelworks just, I can't even start to express just the atmosphere in them was just totally industrial. It was great. And riding on top of the cranes while you were sort of testing them and working on them was also quite fun. Then after that, after Thomas Johnson Shopfitters, I went self-employed. And initially I tried setting up my own company, but because of an organisation called NICEIC, which at that time was designed to stop people setting up their own companies, it was masquerading as a electrical standards agency, but it really wasn't. They had simple rules like, you couldn't get approved by them unless you've been trading for 2 years, and you had to be working out of a proper industrial unit. And when you're starting up on your own, well, obviously you've not got 2 years experience of, actual contracting on your own. And therefore you couldn't get the work that you were aiming for because it required NICEIC approval. And of course, everybody starts working from home because it's the most affordable way to do it. So that was the requirement to have a proper industrial unit, was their sort of catch-22 situation of stopping people starting up. But I did start up. I struggled to get work initially, and then got lucky with Hussman and other companies when I started working freelance for them. That's this project actually complete. And working freelance and just takes a lot of the responsibility away from, you don't need to go and look for work. You don't need to source the money for materials. You don't need to design the jobs, bid, and so on. Suddenly all you're doing is going and subcontracting to companies, and when they need you, they employ you. When they don't need you, it's almost like a holiday. It was great. It worked out really well. Hussman was a refrigeration company, and they did industrial refrigeration equipment, really heavy refrigeration. And I ended up doing lots of things with them. I ended up panel building and going out to the sites and installing the equipment and repairing and testing. It was almost like a second apprenticeship in control systems. It was fantastic. Now I'm going to turn the light off here. I'm not sure how well these will show. I'm going to have to adjust the. There we go. And that's the string of lights complete. And you see, that was a set of tungsten lights. I could plug this into the power meter, but you know what? The power meter. Where is the power meter? I've misplaced the power. There it is. I'll plug it into the power meter and I'll tell you what it's reading. But I wouldn't hold your breath because it's going to be minute. It says 0.6 watts for the whole lot, so pretty much half what it was for one of these tungsten lamps. And also, when you want to change the lights, you just pull them out and put a new LED in, and if an LED fails, you just pull it out again, just strip the LED out the holder and put a new one in. So yeah, getting back to Hussman, was a great company, really ridiculous hours. I mean, hours that were just to the point that I ended up falling asleep at the wheel of the van, which wasn't very good, and you'd come home so absolutely exhausted after working for literally days and nights and days and nights that I literally, came through the door of the flat, pushed it shut, locked it, and just lay down in my overalls on the floor and just slept where I landed. I was so exhausted. So it was good, but also it was just heavy going those days. But latterly, that's pretty much the potted history of my career. Just basically freelancing to just a few companies because I guess I was good enough. They just kept bringing me back, and because I was single and didn't have a huge requirement for money, they just, you can just get by just doing work for half the year and not working for the other half. It's definitely the way to go. When you actually work on your own and you realise that if you're working for a company, you're pretty much paying the wages of the management, and there's a lot of people riding your back. When you're self-employed and you charge a decent, an acceptable rate for a self-employed individual, you don't have to work all the time to get by. It's pretty good. So that was a ramble, a potted history of Clive. Oh, here's the little power supply, by the way. See how bright it is? It's really quite bright indeed. It looks nice. That little red LED inside just acts as a sort of power on indicator. But yeah, so how to convert your tungsten LEDs into, tungsten fairy lights or Christmas lights into a set of LED ones that will run quite happily, just continuously all year for approximately the cost of about 50p for a continuous year's operation 24/7. So yeah, good stuff.